So here we have two equations and two unknown. We need to graph each equation using any method you like. In this case, you can solve both of them for y, get them into form of y is equal to mx plus b formula. With that, we can locate the position of the y-intercept. So for the blue line, my line is going to pass us through point -5 in y-axis. Because the slope is -2, you can use the rise over run method to find another point. So as the red line, if I find the intercept is 2, and then from here, the slope is 1/3. If I move 1 unit up, 3 units to the right, I get back to another point on the line. So I can draw my lines, and wherever these two lines intercept, that would be the solution. So the common solution in this case, as we see, would be -3 and 1. As you can see, if the solution were -3.2 and 1, we were in trouble. Reading that off the graph is not as convenient. So graphing method would be a good method to estimate the position of the intersection and the solution. However, if you want to find the exact number, point of intersection, we can use different methods that we're going to take a look at. So either use the addition method or elimination method or substitution method would give us more accurate answers. To graph these 2 points, you could actually find 2 points instead of writing it in this form. I could go ahead and make a little chart here and say if x is equal to 0, solve for y, or y is equal to 0, solve for x. You could look for x and y intercepts, or you could look for any 2 points to graph these lines. So it doesn't have to be this form. But if you're comfortable with letting these equations to be look like y is equal to mx plus b, locating the y-intercept, and use a slope to graph them, that's fine. So you could use any method to graph the line. We need to get yourself familiar with these terms. We have 3 cases here. Case number 1, the 2 graphs intercept in a single point. This would be case number 1. This is where we have 2 lines that they intercept at some point, and this is the solution. And as you see, these 2 lines are not the same line, so we can call these independent equations. So the equations, the 2 equations is either independent or dependent. So it's pretty simple to remember which is which. If there are 2 lines, 2 separate lines, so they're independent. So if they're, case number 1 is independent. Case number 2 would be there's no solutions because the lines are what? They're parallel. But there are still different lines. So still, they're independent equations. So independent equation would be when the 2 lines intercept at some point, or the 2 lines parallel. These are independent. The only time the equations are dependent are when they're same line, right on top of each other. So this is how you can distinguish whether a dependent or independent. Now, the other point that we need to remember is whether the system is consistent or inconsistent. And that's easy to remember too. If you don't have any solution, would be inconsistent. Otherwise, would be consistent. Whether you have one solution or infinitely many solutions would be consistent. So the only time is inconsistent is when there's no solution. So in the case where the lines are parallel, there's no solution, there's no point of intersection, we call the system inconsistent. Otherwise, would be consistent. The only time is the equations are dependent would be when there would be the same line, otherwise would be independent. So this is how you can remember these 3 cases.